What if everything you thought you knew about the universe was just the tip of the iceberg? The cosmos stretches out in every direction, vast and mysterious. But here's the thing: scientists still can't agree on whether it even has an edge. Is the universe infinite, stretching endlessly into the void? Or does it have a boundary, a place where space itself just stops? And if it does, what's on the other side? These aren't just questions for science fiction. They're some of the most profound mysteries in physics and philosophy today. Think of the universe like a balloon, constantly expanding, with galaxies racing away from each other as space itself stretches. But here's the twist: if you could travel far enough, would you hit a wall? Or would you just keep going forever? And what about the cosmic horizon, the limit of what we can see? Is that the edge, or is there more beyond it, hidden from our view? In this video, we're diving headfirst into the unknown, exploring mind-blowing theories about the edge of the universe. From the cosmic horizon to the multiverse, from the Big Bang to the possibility of other dimensions, we'll unravel the ideas that challenge everything we think we know. So buckle up, because by the end of this journey, you might just see the universe in a whole new way. Ready to explore the edge? Let's go. Let's start with what we can see, the observable universe. Picture this: a giant sphere centered on Earth, stretching out in all directions. This sphere isn't just a random boundary, it's the limit of what we can observe, defined by the speed of light and the age of the universe itself. Because light takes time to travel, the farther we look, the further back in time we're seeing. The cosmic horizon marks the edge of this sphere, the point where light from the earliest moments of the universe has finally reached us after traveling for over 13.8 billion years. Beyond that horizon, it's not that there's nothing there, it's just that light from those regions hasn't had enough time to reach us yet. Now, here's where it gets fascinating. The observable universe isn't the entire universe, it's just the part we can see. Think of it like standing in the middle of a foggy field. You can only see so far before the fog obscures your view, but that doesn't mean the field ends where your vision does. In the same way, the cosmic horizon isn't a physical edge, it's more like a limit to our current understanding. And here's the kicker: the universe might be much, much larger than what we can observe. Some theories even suggest it could be infinite, stretching far beyond what our telescopes will ever reveal. So, what's out there beyond the cosmic horizon? We don't know, and that's the thrilling part. It's like staring at the ocean and wondering what lies beyond the horizon. The observable universe is just the beginning, a tiny fraction of what might exist. And as we peer deeper into the cosmos, we're constantly reminded that the universe is full of mysteries waiting to be uncovered. But how did we get here? To understand the edge of the universe, we have to go back to the very beginning, the Big Bang. This isn't just a theory, it's the foundation of modern cosmology. Around 13.8 billion years ago, the universe burst into existence from an unimaginably hot, dense point. And ever since that moment, it's been expanding, stretching space itself like a cosmic rubber sheet. Picture this: the universe is like a loaf of raisin bread baking in an oven. The dough represents space and the raisins are galaxies. As the bread rises, the raisins move farther apart, not because they're traveling through the dough, but because the dough itself is expanding. In the same way, galaxies aren't just drifting away from each other, they're being carried along as space stretches. This expansion has been happening for billions of years, and it's still going on today. But here's the mind-bending part. If the universe has been expanding for so long, what does that mean for its size? Is it finite, like a balloon that's only so big, or is it infinite, stretching endlessly in all directions? Scientists have been wrestling with this question for decades. Some models suggest the universe could be like the surface of a sphere, finite but without edges. If you traveled far enough in one direction, you might eventually loop back to where you started, like circumnavigating the Earth. Others argue the universe could be flat and infinite, meaning it just goes on forever with no boundary in sight. And then there's the possibility that our universe is just one of many in a vast multiverse, each with its own unique properties. The truth is, we don't know for sure, and that's what makes this so exciting. What's clear, though, is that the Big Bang set the stage for everything we see today. It's the reason galaxies are racing away from each other, the reason we have a cosmic horizon, and the reason we're even asking these questions in the first place. But as we look out into the vastness of space, one thing becomes undeniable. The universe is far stranger and more complex than we ever imagined, and the deeper we dig, the more questions we uncover. So what's next? If the universe is expanding, what does that mean for its future? Could it keep stretching forever, or will it eventually slow down, stop, or even collapse back in on itself? These are the kinds of questions that keep scientists up at night, and they're the ones we'll explore as we continue our journey to the edge of the universe. Now, let's talk about the shape of the universe, because yes, the cosmos might have a shape, and it's not as straightforward as you might think. Scientists have proposed three main possibilities: flat, closed, or open. Each of these shapes tells a different story about how the universe behaves, how it might end, and whether it even has an edge. First, imagine a flat universe. Picture a vast, endless sheet of paper stretching out in all directions. In this scenario, the universe would be infinite, with no boundaries or edges. Light would travel in straight lines forever, and the expansion of space would continue endlessly, driven by dark energy, the mysterious force pushing galaxies apart. A flat universe aligns with many of our current observations, like the way distant galaxies are moving away from us at accelerating speeds. But here's the catch: if the universe is truly flat and infinite, it means there's no edge, just an endless expanse of space, stars, and galaxies. Now let's consider a closed universe. Think of it like the surface of a sphere. If you were to travel in one direction long enough, you'd eventually loop back to where you started. In this model, the universe would be finite but without a hard edge, kind of like how the Earth has no edge even though it's a finite object. A closed universe would eventually stop expanding and could even collapse back in on itself in a big crunch, the opposite of the Big Bang. This shape would require a certain amount of matter and energy to curve space back on itself, and dark matter, the invisible stuff that makes up most of the universe's mass, would play a key role in shaping this cosmic sphere. Finally, there's the open universe, which is a bit harder to visualize. Imagine a saddle, a surface that curves downward in one direction and upward in another. In this scenario, the universe would also be infinite, but space would curve away from itself, creating a kind of cosmic saddle shape. An open universe would expand forever, with galaxies drifting farther and farther apart until they're lost in the void. So, how do we know which shape is correct? Scientists use something called the cosmic microwave background, the faint afterglow of the Big Bang, to measure the curvature of space. So far, the data suggests the universe is flat, but there's still room for debate. And here's where it gets even more intriguing. The shape of the universe isn't just a cool fact. It has profound implications for what lies at the edge, or if there even is one. If the universe is flat or open, it might stretch on forever with no edge in sight. But if it's closed, the edge could be more like a loop, a cosmic return journey. And then there's dark energy, the wild card in all of this. This mysterious force is accelerating the expansion of the universe, and its behavior could ultimately determine whether the cosmos keeps stretching forever or collapses back in on itself. The shape of the universe isn't just a question of geometry, it's a question of destiny. It shapes how we think about the cosmos, its origins, and its ultimate fate. And as we continue to explore these ideas, one thing becomes clear: the universe is far more complex and awe-inspiring than we ever imagined. So, what's next? Let's dive deeper into the role of dark energy and dark matter, and how they might hold the key to understanding the true nature of the cosmos. What if the universe never ends? No edge, no boundary, just an endless expanse of space stretching out in every direction forever. This is the idea of an infinite universe, a concept that challenges everything we think we know about the cosmos. If the universe is infinite, it means no matter how far you travel, you'll never reach the end. You could keep going past galaxies, past stars, past everything we've ever observed, and still there would be more. It's a mind-bending thought, one that forces us to rethink not just the size of the universe, but the very nature of existence itself. Let's try a thought experiment. Imagine you're in a spaceship traveling in a straight line through the universe. You're moving faster than light, hypothetically, of course, and you just keep going. Days turn into years, years into millennia, and still, you're flying through an endless sea of stars and galaxies. In an infinite universe, this journey would never stop. There would always be more space ahead of you, more galaxies to explore, more mysteries to uncover. It's a concept that's both exhilarating and humbling, reminding us just how small we are in the grand scheme of things. But an infinite universe doesn't just challenge our sense of scale. It raises profound questions about the nature of reality. If the universe is truly infinite, then every possible configuration of matter and energy must exist somewhere. That means there could be infinite copies of Earth, infinite versions of you, and even infinite worlds where history unfolded differently. It's a staggering idea, one that blurs the line between science and philosophy. Could there be another version of you right now reading this same script on a distant planet? In an infinite universe, the answer might just be yes. Of course, not everyone agrees with this idea. Some scientists argue that an infinite universe creates more problems than it solves. For one, it's hard to reconcile with the Big Bang theory, which suggests the universe began as a finite, incredibly dense point. If the universe started small, how could it become infinite? Others point to the cosmic microwave background, the afterglow of the Big Bang, which suggests the universe is flat, but not necessarily infinite. A flat universe could still be finite, like the surface of a cylinder, stretching out endlessly in one direction but looping back in another. And then there's the question of dark energy, the mysterious force driving the universe's accelerated expansion. If dark energy continues to push galaxies apart, could it eventually stretch the universe into infinity? Or will it slow down, stop, or even reverse, leading to a finite cosmos? These are the kinds of questions that keep cosmologists up at night, and they're far from being answered. So, is the universe infinite? The truth is, we don't know, and that's what makes this such a fascinating topic. It's a question that pushes the boundaries of science, philosophy, and even our imagination. Whether the universe is infinite or finite, one thing is certain: it's far stranger and more complex than we ever imagined. And as we continue to explore these ideas, we're reminded that the cosmos is full of mysteries waiting to be uncovered. But what if the universe isn't infinite? What if it has a boundary, a place where space itself just stops? That's the idea we'll explore next as we dive into the theories that suggest the cosmos might have an edge after all. What if the universe isn't infinite after all? What if it's finite but without an edge, like the surface of a sphere? This is the idea behind the finite universe theory, and it's one of the most fascinating possibilities in cosmology. Imagine the universe as a giant cosmic balloon, expanding and stretching but with no hard boundary. If you were to travel in a straight line long enough, you wouldn't hit a wall or fall off the edge. You'd eventually loop back to where you started. It's a concept that challenges our everyday understanding of space and forces us to think in entirely new ways. To visualize this, think of a video game world that wraps around. In some games, if you walk far enough in one direction, you'll end up back where you began, as if the world were stitched together at the edges. The finite universe theory suggests something similar. Space itself could be curved in such a way that it loops back on itself. This doesn't mean the universe is small. It could still be unimaginably vast, but it would mean there's a limit to how far you could go before returning to your starting point. Now here's where it gets even more intriguing. If the universe is finite but unbounded, what does that mean for its edge? In this model, there isn't one, at least not in the traditional sense. Instead of a hard boundary, the universe would be seamless, like the surface of a sphere. You could travel forever without ever encountering an edge, but you'd always be moving through a finite amount of space. This idea ties into something called cosmic topology, the study of the universe's shape and structure on the largest scales. Cosmic topology is like trying to map the universe's global geometry. Is it flat, curved, or twisted in some way? And if it's curved, how does that curvature affect the way space behaves? These questions aren't just academic, they have real implications for how we understand the cosmos. For example, if the universe is finite and curved, it could mean that light from distant objects has traveled around the curve, creating ghostly echoes or repeating patterns in the cosmic microwave background. But here's the catch: we haven't found definitive evidence of this yet. The cosmic microwave background, our best snapshot of the early universe, suggests the cosmos is flat on large scales. But that doesn't rule out the possibility of a finite universe entirely. It could be that the universe is so vast that its curvature is too subtle for us to detect, or that it's shaped in a way we haven't even imagined yet. The finite universe theory opens up a world of possibilities, from the idea of cosmic loops to the potential for hidden patterns in the fabric of space. It's a reminder that the universe is full of surprises, and that even the most fundamental questions, like whether it has an edge, are still up for debate. So, what's next? As we continue to explore the mysteries of cosmic topology, we'll uncover even more clues about the true nature of the cosmos, and who knows? The answers might be closer than we think, or they might be hiding just beyond the curve. Now, let's take a closer look at cosmic topology, the study of the universe's shape and structure on the grandest scales. This isn't just about whether the cosmos is flat, closed, or open. It's about understanding the intricate geometry of space itself. Imagine trying to map the universe not just as a vast expanse, but as a complex, interconnected system with its own unique patterns and symmetries. Cosmic topology asks, does the universe have a repeating structure? Could it loop back on itself in ways we can't yet see? And if so, what would that mean for the nature of reality? One of the most intriguing ideas in cosmic topology is the dodecahedral space model. Picture a dodecahedron, a 12-sided shape like a soccer ball. Now imagine that the universe is shaped like this, but on a cosmic scale. In this model, space could be finite but still appear infinite because it loops back on itself in a repeating pattern. If you traveled far enough in one direction, you might find yourself returning to your starting point, but everything would look slightly shifted, like a cosmic hall of mirrors. This model isn't just a wild guess, it's based on patterns scientists have observed in the cosmic microwave background, the faint glow left over from the Big Bang. Speaking of the cosmic microwave background, it's one of the most powerful tools we have for studying cosmic topology. Think of it as a cosmic fingerprint, a snapshot of the universe when it was just a few 100,000 years old. By analyzing the tiny temperature fluctuations in this ancient light, scientists can search for clues about the universe's shape and structure. For example, if the universe were shaped like a dodecahedron, we might see repeating patterns or anomalies in the cosmic microwave background that hint at its geometry. So far, the evidence is inconclusive, but the search continues, and every new discovery brings us closer to understanding the true nature of the cosmos. But cosmic topology doesn't just stop at the shape of our universe. It opens the door to even bigger questions, like the possibility of a multiverse. If our universe has a finite, repeating structure, could there be other universes out there, each with its own unique topology? The multiverse theory suggests that our universe might be just one of many, like bubbles in a cosmic foam. Some of these universes could be flat, others curved, and some might even have shapes we can't yet imagine. And if that's the case, the edge of our universe might not be an edge at all. It could be a boundary where our universe meets another, like neighboring rooms in an infinite cosmic mansion. This idea ties back to the question of what lies beyond the observable universe. If the multiverse exists, the edge of our universe might not be a hard stop. It could be a transition point, a place where one universe gives way to another. And if that's true, it changes everything we thought we knew about the cosmos. Instead of a single, isolated universe, we might be part of a vast, interconnected network of realities, each with its own rules and possibilities. Cosmic topology reminds us that the universe is far more than just a collection of stars and galaxies. It's a dynamic, evolving system with a shape and structure that we're only beginning to understand. Whether it's a dodecahedral space, a flat expanse, or something even more exotic, the geometry of the cosmos holds the key to some of the deepest mysteries in science. And as we continue to explore these ideas, we're not just mapping the universe, we're mapping the very fabric of reality itself. So, what's next? As we venture further into the unknown, we'll explore how the multiverse theory reshapes our understanding of the cosmos and what it might mean for the edge of our universe. The journey is far from over, and the answers we find might just redefine everything we thought we knew. What if our universe isn't alone? What if it's just one tiny bubble floating in an endless sea of other universes, each with its own unique laws of physics, its own stars, its own stories? This is the multiverse hypothesis, one of the most mind-bending ideas in modern science. It suggests that our universe might be just one of countless others, each existing in its own pocket of reality. And if that's true, the edge of our universe might not be an edge at all. It could be a boundary, a place where our cosmos meets another. The multiverse idea doesn't come out of thin air. It's rooted in some of the most advanced theories in physics. Take quantum mechanics, for example. At the smallest scales, particles behave in strange, unpredictable ways, and some interpretations suggest that every possible outcome of a quantum event actually happens, just in different universes. Then there's string theory, which proposes that the fundamental building blocks of reality are tiny, vibrating strings. String theory requires extra dimensions of space, and some versions of it suggest these dimensions could give rise to multiple universes. But perhaps the most compelling evidence for the multiverse comes from cosmic inflation, the rapid expansion of the universe just after the Big Bang. According to this theory, our universe ballooned from a tiny speck to an enormous expanse in a fraction of a second. But here's the twist: inflation might not have stopped everywhere. In some regions, it could still be happening, creating new universes all the time. Picture a pot of boiling water with bubbles constantly forming and popping. In this analogy, each bubble is a universe, and the foam is the multiverse, a vast, bubbling sea of realities. Now, let's take this a step further. If the multiverse exists, what does that mean for the edge of our universe? Instead of a hard boundary, the edge might be more like a transition zone, a place where our bubble universe meets another. Imagine standing at the edge of a soap bubble, looking out at the neighboring bubbles. You might see glimpses of other worlds, other realities, but you'd never be able to cross over, at least not with our current understanding of physics. The multiverse hypothesis isn't just one idea. It's a whole family of theories, each with its own flavor. For example, there's the bubble multiverse, where each universe is a separate bubble in a cosmic foam. Then there's the brain multiverse, inspired by string theory, which suggests our universe is a three-dimensional brain floating in a higher dimensional space alongside other brains. And let's not forget the many worlds interpretation of quantum mechanics, where every decision you make spawns a new universe, creating an infinite tree of parallel realities. Each of these theories offers a different perspective on the multiverse, but they all share one thing in common: they challenge our understanding of reality. If the multiverse exists, it means our universe is just one small piece of a much larger puzzle, a puzzle we're only beginning to piece together. So, what's next? As we explore the multiverse, we'll dive deeper into these theories, uncovering the clues that might one day prove or disprove the existence of other universes. The journey is just beginning, and the answers we find could change everything we thought we knew about the cosmos. Now, let's zoom in on one of the most fascinating ideas in the multiverse hypothesis: bubble universes. Imagine a vast cosmic ocean filled with countless soap bubbles, each one shimmering and floating independently. In this analogy, each bubble represents a separate universe, complete with its own unique set of physical laws, constants, and even dimensions. Some bubbles might be filled with stars and galaxies, while others could be utterly alien, governed by rules we can't even begin to comprehend. This is the concept of bubble universes, and it's a cornerstone of the multiverse theory. So, how do these bubbles form? The answer lies in cosmic inflation, the rapid expansion of the universe that occurred just moments after the Big Bang. Picture this: in the earliest moments of existence, the universe underwent an exponential growth spurt, stretching from a tiny speck to an enormous expanse in less than a blink of an eye. But here's the twist: inflation might not have stopped everywhere. In some regions, it could still be happening, creating new pockets of space that balloon into their own separate universes. Think of it like a pot of boiling water where bubbles constantly form, grow, and sometimes collide. In the multiverse, each bubble is a universe, and the foam is the endless sea of realities. Now, here's where it gets even more intriguing. If our universe is one of these bubbles, what does that mean for its edge? Instead of a hard boundary, the edge of our universe might be more like the surface of a bubble, a thin, delicate membrane separating us from other universes. Beyond that membrane, there could be an infinite number of other bubbles, each with its own unique properties. Some might be similar to ours, with stars, planets, and life. Others could be wildly different, with physics so alien that they defy our understanding. To visualize this, think of soap bubbles floating in the air. When two bubbles collide, they don't merge into chaos. They form a boundary, a shared wall where their surfaces meet. In the same way, if two bubble universes were to collide, they might create a kind of cosmic boundary, a place where their physical laws interact or overlap. This idea isn't just theoretical. Some scientists have even proposed that certain anomalies in the cosmic microwave background could be evidence of such collisions, like cosmic fingerprints left behind by a neighboring universe. But what if these bubble universes aren't just separate? What if they're parallel? This brings us to the idea of parallel universes, a concept that takes the multiverse theory to a whole new level. In a parallel universe, every decision you make could spawn a new reality, creating an infinite web of possibilities. Did you take that job offer? In one universe, you did. In another, you didn't. Did you turn left instead of right? There's a universe for that too. It's a dizzying thought, one that challenges our understanding of choice, fate, and even identity. The bubble universe model doesn't just expand our view of the cosmos, it reshapes it entirely. It suggests that the edge of our universe isn't a dead end, but a gateway to infinite possibilities. And as we continue to explore these ideas, we're reminded that the universe, or universes, are far stranger and more complex than we ever imagined. So, what's next? As we dive deeper into the multiverse, we'll explore how these parallel realities might interact, collide, or even coexist. The journey is just beginning, and the answers we find could redefine everything we thought we knew about existence itself. What if every choice you've ever made, and every choice you could have made, exists somewhere out there in a parallel universe? This is the idea behind parallel universes, a concept that takes the multiverse theory to a whole new level. Imagine a reality where you took that job offer, or where you turned left instead of right at the intersection. In this mind-bending framework, every possible outcome of every event plays out in its own separate universe, creating an infinite web of realities. This idea isn't just science fiction, it's rooted in quantum mechanics, the branch of physics that deals with the behavior of particles at the smallest scales. One of the most famous interpretations of quantum mechanics is the many worlds theory, which suggests that every time a quantum event occurs, the universe splits into multiple branches. Think of it like a tree where every decision or random event creates a new branch leading to a new universe. To understand this better, let's revisit a classic thought experiment, Schrödinger's cat. In this scenario, a cat is placed in a box with a device that has a 50% chance of releasing poison. According to quantum mechanics, until the box is opened, the cat exists in a superposition. It's both alive and dead at the same time. But the many worlds interpretation takes this a step further. It suggests that when the box is opened, the universe splits into two, one where the cat is alive and another where it's dead. Both realities exist simultaneously, just in different branches of the multiverse. Now, here's where it gets even more fascinating. If parallel universes exist, what does that mean for the edge of our universe? Could it be a kind of gateway, a place where our reality meets another? Imagine standing at the boundary of our cosmos, looking out into the void. Instead of emptiness, you might see glimpses of other universes, each with its own version of history, physics, and even life. It's a staggering thought, one that blurs the line between science and imagination. But how do we get from parallel universes to higher dimensions? That's where things get even more intriguing. Some theories suggest that these parallel realities might not just exist out there. They could be stacked in higher dimensions like pages in a book. In this model, our three-dimensional universe is just one layer in a much larger, multidimensional structure. To visualize this, think of a two-dimensional creature living on a flat piece of paper. To them, the concept of up or down would be incomprehensible. They can only move left, right, forward, or backward. But to us, as three-dimensional beings, we can see and move in ways they can't even imagine. Now, apply that idea to our universe. If higher dimensions exist, they could be the key to understanding how parallel universes are connected, or even how they overlap. Some theories propose that these dimensions might be curled up so tightly that we can't perceive them, like the fibers of a carpet. Others suggest that higher dimensions could act as bridges between universes, allowing for interactions or even travel between realities. The idea of parallel universes and higher dimensions isn't just a wild speculation, it's a framework that challenges our understanding of reality itself. It forces us to ask, are we alone in the cosmos, or are there infinite versions of us, living out every possible life in an endless sea of realities? And if so, what does that mean for the nature of existence? As we explore these questions, we're reminded that the universe or universes are far stranger and more complex than we ever imagined. The journey doesn't end here, though. Next, we'll dive deeper into the concept of higher dimensions, uncovering how they might hold the key to unlocking the true nature of the cosmos. The answers we find could change everything we thought we knew about the edge of the universe and beyond. What if the universe we see is just a shadow of something much larger? What if the three dimensions we experience, length, width, and height, are only a fraction of the full picture? This is the idea behind higher dimensions, a concept that stretches the limits of our imagination and challenges everything we think we know about reality. According to some of the most advanced theories in physics, our universe might exist within a framework of up to 11 dimensions we can't see or touch. But that could hold the key to understanding the true nature of the cosmos. Let's start with a simple analogy. Imagine a two-dimensional creature living on a flat piece of paper. To this creature, the world is limited to left, right, forward, and backward. The concept of up or down would be completely foreign. It's a dimension they can't perceive or interact with. Now, imagine you as a three-dimensional being. Reach down and lift this creature off the paper. From their perspective, they've just vanished from their world and reappeared somewhere else as if by magic. To you, it's simple. You moved them through a dimension they couldn't comprehend. This is the essence of higher dimensions. Just as the 2D creature can't perceive the third dimension, we might be unable to perceive dimensions beyond our own. String theory, one of the leading frameworks in modern physics, suggests that these extra dimensions could be curled up so tightly that they're invisible to us like the fibers of a carpet. But if we could uncurl them, we might discover a whole new layer of reality, one that could explain some of the deepest mysteries in the universe. So how many dimensions are we talking about? String theory proposes up to 11 dimensions, each with its own unique properties. Some of these dimensions might be compactified, meaning they're so small that we can't detect them directly. Others could be vast, stretching far beyond what we can observe. And here's where it gets even more fascinating. These extra dimensions might not just be hiding in the background. They could be shaping the very fabric of our universe. For example, gravity, the force that holds galaxies together, is surprisingly weak compared to the other fundamental forces. Some scientists believe this could be because gravity leaks into higher dimensions, spreading its influence across realities we can't see. If that's true, it would mean our understanding of gravity and the universe itself is incomplete. But what does this have to do with the edge of the universe? If higher dimensions exist, they could fundamentally change how we think about boundaries. Instead of a hard edge, the universe might wrap around into these extra dimensions, creating a kind of cosmic loop. Imagine a sphere. If you travel far enough in one direction, you'll eventually loop back to where you started. In the same way, the universe might not have an edge in the traditional sense. It could just curve into higher dimensions, creating a seamless, boundless reality. This idea ties into something called the Holographic Principle, a theory that suggests the entire universe could be encoded on a two-dimensional surface like a cosmic hologram. In this model, the three-dimensional world we experience might just be a projection of information stored on a distant boundary. It's a radical idea, one that blurs the line between reality and illusion, and it's rooted in the possibility of higher dimensions. As we explore these concepts, we're reminded that the universe is far stranger and more complex than we ever imagined. Higher dimensions aren't just a theoretical curiosity, they're a window into a deeper understanding of reality, one that could reshape our view of the cosmos and our place within it. So, what's next? Let's dive deeper into the holographic principle and uncover how it might hold the key to unlocking the true nature of the universe's edge and beyond. What if everything we see, touch, and experience is just a projection, a cosmic illusion? This is the heart of the holographic principle, a theory that turns our understanding of reality on its head. Imagine the universe as a giant hologram where all the information about the cosmos, every star, every galaxy, every particle, is encoded on a two-dimensional surface. It's like a 3D movie projected from a flat screen, except in this case, the screen is the edge of the universe itself. The holographic principle didn't come out of nowhere. It has deep roots in black hole physics and quantum gravity. In the 1970s, physicist Jacob Bekenstein discovered that the amount of information a black hole can contain isn't proportional to its volume, but to its surface area. This was a groundbreaking idea, suggesting that the information about everything inside a black hole could be stored on its boundary or event horizon. Later, physicist Leonard Susskind and others expanded this idea, proposing that the entire universe might work the same way. To understand this, think of a hologram. A hologram is a two-dimensional surface that, when illuminated, creates a three-dimensional image. In the same way, the holographic principle suggests that our three-dimensional universe might be a projection from a two-dimensional boundary. This boundary could be the edge of the observable universe or even the cosmic horizon, the limit of what we can see. every star, every planet, every atom might just be information encoded on this cosmic screen, like pixels in a vast universal image. But how does this connect to the edge of the universe? If the holographic principle is correct, the edge isn't just a boundary, it's a kind of cosmic hard drive, storing all the information needed to create the universe as we know it. It's as if the entire cosmos is a holographic projection, with the edge acting as the source of that projection. This idea challenges our everyday understanding of space and time, suggesting that the universe might be far more interconnected and far stranger than we ever imagined. Now, let's take this a step further. If the universe is a hologram, what does that mean for the cosmic void, the vast, empty regions of space between galaxies? In the holographic framework, even the void might not be truly empty. Instead, it could be filled with information encoded in ways we can't yet perceive. This idea ties into quantum gravity, the quest to unify quantum mechanics and general relativity. In this view, the void isn't just nothingness, it's a dynamic, information-rich space playing a crucial role in the structure of the cosmos. The holographic principle isn't just a wild theory, it's a framework that could help us solve some of the deepest mysteries in physics, from the nature of black holes to the origins of the universe itself. It's a reminder that reality might be far more complex and far more beautiful than we ever imagined. So, what's next as we explore the cosmic void? We'll uncover how these vast, empty regions of space might hold the key to understanding the true nature of the universe, and perhaps even the edge of reality itself. The journey is far from over, and the answers we find could change everything we thought we knew about the cosmos. What if the universe is like an island floating in an endless ocean of nothingness? This is the idea behind the cosmic void, a theory that suggests our universe might be surrounded by an infinite expanse of emptiness, with no edge, no boundary, and no beyond. It's a concept that challenges our understanding of space and raises profound questions about the nature of existence itself. To visualize this, picture the universe as an island in the middle of a vast, featureless ocean. The island is teeming with life, energy, and complexity: galaxies, stars, planets, and everything we know. But beyond its shores, there's nothing. No land, no waves, no horizon, just an infinite void stretching out in every direction. In this analogy, the ocean represents the cosmic void, a place where space and time as we know them simply don't exist. This idea isn't just a thought experiment, it's rooted in some interpretations of the Big Bang and cosmic expansion. When the universe began, it exploded into existence from an incredibly dense, hot point. As it expanded, it created space itself, stretching out like the surface of a balloon. But here's the question: what's outside that balloon? If the universe is expanding into something, what is that something? The cosmic void theory suggests there's nothing, no space, no time, no matter. Just an infinite, empty expanse. But what does nothing really mean? It's not just the absence of matter or energy. It's the absence of everything, including the very fabric of space and time. Imagine trying to describe a place where the rules of physics don't apply, where concepts like distance and duration have no meaning. It's a mind-bending idea, one that pushes the limits of our imagination and forces us to rethink what nothingness truly is. Now, here's where it gets even more intriguing. If the universe is surrounded by an infinite void, what does that mean for its future? Could it keep expanding forever, drifting further into the emptiness? Or will it eventually slow down, stop, or even collapse back in on itself? These are the kinds of questions that keep cosmologists up at night, and they're far from being answered. But the cosmic void isn't just a question of physics, it's also a question of philosophy. If the universe is an island in an endless ocean of nothingness, what does that say about our place in the cosmos? Are we alone, adrift in an infinite void, or is there something more out there waiting to be discovered? As we ponder these questions, another idea comes to mind. What if the universe isn't just floating in a void? What if it's a simulation? This might sound like science fiction, but it's a theory that's gaining traction among some scientists and philosophers. The idea is that our universe could be a kind of cosmic computer program, created by an advanced civilization or even by some higher dimensional intelligence. In this scenario, the cosmic void might not be empty at all. It could be the code running the simulation, the underlying framework that makes our reality possible. It's a radical idea, one that blurs the line between science and philosophy, and it raises even more questions about the nature of existence. So, what's next? As we explore the cosmic void and the simulation hypothesis, we'll uncover how these ideas might hold the key to understanding the true nature of the universe, and perhaps even the edge of reality itself. The journey is far from over, and the answers we find could change everything we thought we knew about the cosmos. What if everything we experience, every star, every galaxy, even every thought, is just lines of code in an unimaginably advanced simulation? This is the simulation hypothesis, a theory that suggests our universe might not be real in the traditional sense, but rather a digital construct created by an intelligent civilization far beyond our understanding. It's a concept that sounds like science fiction, but it's one that some scientists and philosophers take seriously. And if it's true, it could completely redefine what we think of as the edge of the universe. To grasp this idea, think of the movie The Matrix. In that story, humans live in a simulated reality, unaware that their world is just a computer program. The simulation hypothesis takes this concept to a cosmic scale, proposing that the entire universe, not just Earth, could be a simulation. In this scenario, the edge of the universe might not be a physical boundary at all. Instead, it could be the limits of the simulation itself, like the edge of a video game map. Beyond that edge, there might be nothing, or perhaps the code that makes our reality possible. But how could we even begin to test such a wild idea? Some scientists have proposed looking for glitches in the simulation, tiny anomalies in the laws of physics that could hint at the underlying code. For example, if the universe is a simulation, it might have a kind of resolution limit like pixels on a screen. At extremely small scales, we might find that space and time aren't smooth and continuous, but instead made up of discrete units like the frames of a movie. These clues could be the key to uncovering the true nature of reality. The simulation hypothesis doesn't just challenge our understanding of the universe, it challenges our understanding of ourselves. If we're living in a simulation, what does that mean for free will, consciousness, and the nature of existence? Are we just characters in someone else's story, or do we have the power to shape our own reality? These are questions that blur the line between science and philosophy, and they force us to confront the possibility that the universe might be far stranger than we ever imagined. Now, let's take this a step further. If the universe is a simulation, could it be part of a larger cycle? This brings us to the idea of cyclic universes, a theory that suggests our universe might not be the first or the last. Instead, it could be one in an endless series of universes, each one born from the collapse or rebirth of the last. In this model, the edge of our universe might not be a boundary, but a transition point, a place where one simulation ends and another begins. The simulation hypothesis and cyclic universes might seem like wildly different ideas, but they share a common thread. They both challenge our understanding of reality. Whether we're living in a simulation or part of an endless cycle of universes, these theories remind us that the cosmos is full of mysteries waiting to be uncovered. And as we continue to explore these ideas, we're not just pushing the boundaries of science, we're pushing the boundaries of what it means to exist. So, what's next? As we dive deeper into the concept of cyclic universes, we'll uncover how these theories might hold the key to understanding the true nature of the cosmos, and perhaps even the edge of reality itself. The journey is far from over, and the answers we find could change everything we thought we knew about the universe. What if the universe isn't just a one-time event, but part of an endless cosmic dance, a cycle of birth, death, and rebirth that repeats itself over and over again? This is the idea behind cyclic universes, a theory that suggests our cosmos might not have a definitive beginning or end. Instead, it could be caught in an eternal loop, expanding and contracting like a cosmic heartbeat. And if that's true, the edge of the universe might not be an edge at all. It could be a transition point, a place where one cycle ends and another begins. To understand this, let's start with the Big Bang. Most of us think of it as the moment the universe began, but what if it wasn't the first? What if it was just the latest in an infinite series of cosmic explosions? This is the essence of the Big Bounce theory, which proposes that the universe doesn't end in a big crunch, a collapse back into a single point, but instead rebounds, starting the cycle all over again. Picture a rubber ball bouncing on the ground. It compresses, then springs back over and over. In the same way, the universe might expand, contract, and then expand again in an endless rhythm. Now, here's where it gets fascinating. If the universe is cyclic, what happens at the edge in this model? The edge isn't a hard boundary. It's more like a cosmic reset button. As the universe contracts, galaxies, stars, and even space itself are pulled back together, collapsing into an incredibly dense state. But instead of ending there, the universe rebounds, exploding outward in a new Big Bang. The edge, in this case, is the moment of transition, the point where one cycle ends and another begins. But what drives this cosmic heartbeat? The answer lies in the delicate balance between two opposing forces, dark energy and gravity. Dark energy, the mysterious force pushing galaxies apart, is what's causing the universe to expand at an accelerating rate. Gravity, on the other hand, pulls everything together. In a cyclic universe, these forces are locked in a cosmic tug-of-war. For billions of years, dark energy dominates, driving the expansion. But eventually, gravity might gain the upper hand, pulling everything back together and setting the stage for the next Big Bang. This idea isn't just theoretical, it's supported by some of the most advanced models in physics. For example, string theory and quantum gravity suggest that the universe could survive a big crunch, emerging on the other side as a new, reborn cosmos. It's a concept that challenges our understanding of time, space, and the very nature of existence. So, what does this mean for the ultimate fate of the universe? If the Big Bounce theory is correct, the cosmos might not have an end, just an endless series of beginnings. Each cycle could be slightly different, with new laws of physics, new galaxies, and even new forms of life. It's a vision of the universe that's both awe-inspiring and humbling, reminding us that the cosmos is far more dynamic and resilient than we ever imagined. As we explore these ideas, we're not just uncovering the secrets of the universe, we're uncovering the secrets of existence itself. The journey doesn't end here, though. Next, we'll dive deeper into the ultimate fate of the cosmos, exploring how these cycles might shape the destiny of everything we know and everything we don't. The answers we find could change everything we thought we knew about the edge of the universe and beyond. Now, let's shift our focus to one of the most haunting possibilities for the universe's ultimate fate, the heat death. Imagine a campfire on a cold night, crackling and glowing as it burns through its fuel. At first, it's warm and bright, but over time, the flames grow weaker, the embers fade, and eventually, all that's left is cold, dark ash. This is the essence of the heat death theory, a scenario where the universe, like that campfire, slowly burns out, leaving behind a cold, lifeless void. The heat death theory is rooted in the concept of entropy, a measure of disorder in a system. Over time, entropy always increases, meaning systems naturally move toward chaos and equilibrium. In the universe, this means energy becomes more evenly distributed, and usable energy, the kind that powers stars, galaxies, and life itself becomes scarce. Eventually, stars will exhaust their fuel, galaxies will drift apart, and even black holes will evaporate over unimaginable timescales. The result, a universe that's dark, cold, and utterly still. But what does this mean for the edge of the universe? If the heat-death scenario plays out, the edge might not be a physical boundary, but a kind of cosmic exhaustion, a point where the universe has expanded so much that everything is spread so thin. It's as if the cosmos itself has run out of steam. In this state, the universe wouldn't have an edge in the traditional sense. Instead, it would be a vast, empty expanse where nothing happens and nothing ever will. This raises a profound question. What lies beyond the edge of a dying universe? If the cosmos reaches heat death, could there still be something beyond it? Some theories suggest that even in this state, the universe might not be truly dead. Quantum fluctuations, tiny, random changes in energy, could still occur, potentially sparking new universes or even new cycles of existence. It's a faint glimmer of hope in an otherwise bleak scenario, a reminder that even in the darkest corners of the cosmos, there might still be the potential for something new. Now, let's take this a step further. While the heat death paints a picture of a slow, quiet end, there's another possibility that's far more dramatic: the Big Rip. Imagine the universe not as a campfire burning out, but as a piece of fabric being torn apart. In this scenario, dark energy, the mysterious force driving the universe's accelerated expansion, becomes so powerful that it overcomes all other forces, ripping apart galaxies, stars, planets, and even atoms themselves. The Big Rip is a stark contrast to the heat death. Instead of a gradual fade into darkness, it's a violent, explosive end where the very fabric of reality is torn to shreds. And here's the chilling part: if the Big Rip happens, the edge of the universe wouldn't just be a boundary, it would be a point of no return, a place where space itself is stretched to its breaking point. Both the heat death and the Big Rip offer starkly different visions of the universe's end, but they share one thing in common: they force us to confront the fragility of existence. Whether the cosmos fades quietly or is torn apart violently, these theories remind us that the universe is not eternal. It has a beginning and it will have an end. So, what's next? As we explore these ideas, we'll uncover how the ultimate fate of the universe might hold the key to understanding not just the edge of reality, but the very nature of existence itself. The journey is far from over, and the answers we find could change everything we thought we knew about the cosmos. Now, let's explore one of the most dramatic possibilities for the universe's fate: the Big Rip. Imagine the universe as a vast cosmic tapestry, woven together by the forces of gravity, electromagnetism, and the mysterious dark energy that's pushing everything apart. Now picture that tapestry being pulled at the edges, stretched tighter and tighter until it begins to fray. At first, the threads hold, but eventually, the tension becomes too much and the fabric starts to tear. This is the essence of the Big Rip, a scenario where dark energy grows so powerful that it overcomes all other forces, ripping apart galaxies, stars, planets, and even the very fabric of space and time itself. The Big Rip theory hinges on the behavior of dark energy, the enigmatic force driving the universe's accelerated expansion. Right now, dark energy is pushing galaxies apart, but in this scenario, it doesn't just keep expanding the universe, it becomes stronger over time. Eventually, it would overpower gravity, the force that holds galaxies together, and even the nuclear forces that bind atoms. The result, a universe torn apart at every level, from the largest structures to the smallest particles. To visualize this, think of a rubber band being stretched. At first, it holds its shape, but as you pull harder, it begins to thin and weaken. If you keep pulling, it eventually snaps. In the Big Rip scenario, the universe is that rubber band, and dark energy is the force pulling it apart. First, galaxies would be ripped from their clusters, then stars from their galaxies, and finally, atoms from molecules. Even space itself would be stretched to its breaking point, creating a definitive edge, a point where the universe as we know it simply ceases to exist. But what does this mean for the nature of space and time? In a big rip scenario, the very fabric of reality would be torn apart, leaving behind a chaotic, fragmented void. Time, as we understand it, would lose all meaning as there would be no coherent structure to measure it against. Space, too, would become a patchwork of disconnected fragments, each isolated from the others. It's a stark and unsettling vision of the universe's end, one that challenges our understanding of existence itself. Now, let's contrast this with another possibility, the Big Crunch. While the Big Rip envisions the universe being torn apart, the Big Crunch suggests the opposite, a universe that collapses back in on itself. Imagine that cosmic tapestry again, but this time, instead of being pulled apart, it's being gathered up, folding in on itself until everything is compressed into an incredibly dense point. This is the Big Crunch, a scenario where gravity eventually overcomes dark energy, pulling the universe back together in a cosmic reversal of the Big Bang. In this model, the edge of the universe isn't a place where space is torn apart. It's a moment in time, a point where the universe reaches its maximum expansion and begins to contract. Galaxies would stop moving apart and start moving closer together, eventually colliding and merging. Stars would burn out, black holes would consume everything in their path, and the universe would shrink back to the incredibly hot, dense state from which it began. The Big Crunch and the Big Rip represent two very different visions of the universe's fate, but they both force us to confront the same question: what happens at the edge of existence? Whether the cosmos is torn apart or collapses in on itself, these theories remind us that the universe is not static. It's a dynamic, ever-changing system, shaped by the delicate balance of forces we're only beginning to understand. As we continue to explore these ideas, we're reminded that the universe is full of mysteries waiting to be uncovered. The journey doesn't end here, though. Next, we'll dive deeper into the concept of the Big Crunch, uncovering how this cosmic collapse might hold the key to understanding the true nature of the universe and perhaps even its rebirth. The answers we find could change everything we thought we knew about the edge of reality and beyond. Now, let's turn our attention to a theory that flips the script on the universe's fate, the Big Crunch. While the Big Rip envisions the cosmos being torn apart, the Big Crunch suggests a very different ending, one where the universe collapses back in on itself, reversing the expansion that began with the Big Bang. Picture a balloon being inflated, then slowly deflated, shrinking back to its original size. In this scenario, the universe isn't expanding endlessly, it's contracting, pulled back together by the relentless force of gravity. At the heart of the Big Crunch theory is gravity, the same force that keeps planets orbiting stars and galaxies bound together. Right now, dark energy is pushing the universe apart, but if gravity were to gain the upper hand, it could reverse that expansion, pulling everything back into an incredibly dense, hot state. This process wouldn't happen overnight. It would take billions, even trillions of years, but eventually, galaxies would stop moving apart and start moving closer together. Stars would collide, black holes would merge, and the universe would shrink back to a single point, a singularity much like the one from which it began. So, what does this mean for the edge of the universe? In the Big Crunch model, the edge isn't a physical boundary, it's a moment in time, a point where the universe reaches its maximum expansion and begins to collapse. Imagine standing on the surface of that deflating balloon. As it shrinks, the space around you contracts, pulling everything closer together. The edge, in this case, is the moment when the universe stops expanding and starts collapsing, a cosmic turning point that marks the beginning of the end. But here's where it gets even more fascinating. If the universe collapses back into a singularity, could it be the start of something new? Some theories suggest that the Big Crunch might not be the end, it could be the beginning of another cycle, a cosmic reset that leads to a new Big Bang. In this model, the universe isn't just a one-time event. It's part of an endless cycle of expansion and contraction, like a cosmic heartbeat. This idea ties into something called the cyclic universe theory, which proposes that the universe goes through an infinite series of Big Bangs and Big Crunches, each one giving rise to a new cosmos. It's a vision of the universe that's both awe-inspiring and humbling, reminding us that the cosmos is far more dynamic and resilient than we ever imagined. As we explore these ideas, we're reminded that the universe is full of mysteries waiting to be uncovered. Whether it's the Big Crunch, the Big Rip, or something entirely different, these theories challenge our understanding of existence itself. And as we continue to push the boundaries of science, we're not just uncovering the secrets of the universe, we're uncovering the secrets of our own place within it. So, what's next? As we delve deeper into the mysteries of the cosmos, we'll explore how these cycles of expansion and contraction might hold the key to understanding the true nature of the universe, and perhaps even its ultimate beginning. The journey is far from over, and the answers we find could change everything we thought we knew about the edge of reality and beyond. Now, let's zoom in on one of the most enigmatic ideas in cosmology, the singularity. This isn't just a point in space, it's a moment in time, a state of infinite density where the laws of physics as we know them break down. It's the birthplace of the universe, the spark that ignited the Big Bang, and it might just hold the key to understanding the true edge of existence. To grasp the singularity, think of a black hole. At the center of a black hole lies a point of infinite density, where gravity is so intense that not even light can escape. The singularity is like that, but on a cosmic scale. It's the point where all the matter, energy, and space in the universe were compressed into an infinitely small, infinitely dense state. From this unimaginable point, the universe exploded into existence, expanding and cooling over billions of years to become the cosmos we know today. But here's the mind-bending part. If the singularity is the starting point of the universe, could it also be its edge? In a sense, the singularity represents the ultimate boundary, not just in space but in time. It's the moment before time itself began, the point where the universe was so compressed that it defies our understanding of physics. To explore the singularity is to peer into the very heart of existence, to ask questions about what came before the Big Bang and what lies beyond the edge of reality. Now, let's take this a step further. If the singularity is the true edge of the universe, what does that mean for the nature of space and time? Some scientists believe that at the singularity, the fabric of reality becomes so warped that space and time cease to exist as we know them. It's like trying to describe the center of a black hole. Our current laws of physics simply can't handle it. This is where quantum mechanics and general relativity collide, creating a puzzle that could hold the universe's deepest secrets. To make this even more relatable, imagine the universe as a vast ocean. The singularity is like the deepest point in that ocean, a place where the pressure is so intense that the water itself behaves in ways we can't fully understand. Just as the ocean floor holds clues to the Earth's history, the singularity might hold clues to the universe's origins and its ultimate fate. But what happens when we try to look even closer, to peer into the fabric of space itself? This brings us to the concept of quantum foam, a chaotic, seething sea of energy that exists at the smallest scales. Picture the surface of a bubbling pot of water, where tiny bubbles constantly form and pop. In the same way, quantum foam suggests that space itself is constantly fluctuating, with particles and energy appearing and disappearing in a frenzied dance. Quantum foam isn't just a theoretical curiosity, it's a window into the fundamental nature of reality. At the Planck scale, the smallest possible size in the universe, space and time become fuzzy, like a blurry photograph. This is where the singularity might reside, a place where the rules of physics as we know them no longer apply. It's a reminder that the universe is far stranger and more complex than we ever imagined, and that the edge of reality might be closer and more mysterious than we think. As we explore these ideas, we're not just uncovering the secrets of the universe, we're uncovering the secrets of existence itself. The journey doesn't end here, though. Next, we'll dive deeper into the quantum realm, uncovering how these tiny fluctuations might hold the key to understanding the true nature of the cosmos, and perhaps even the edge of reality itself. The answers we find could change everything we thought we knew about the universe. Now, let's zoom in even further down to the smallest scales imaginable, where the fabric of space and time itself becomes a chaotic, frothy sea. This is the realm of quantum foam, a concept that takes us to the very edge of what we can understand about reality. Imagine a bubbling pot of water where tiny bubbles constantly form, pop, and reappear in a frenzied dance. At the quantum level, space itself behaves in a similar way, with particles and energy fluctuations appearing and disappearing in a turbulent, ever-changing foam. Quantum foam isn't just a poetic metaphor, it's a real phenomenon predicted by the strange rules of quantum mechanics and general relativity. At the Planck scale, the smallest possible size in the universe, space and time lose their smooth, continuous nature. Instead, they become a seething, chaotic mess where the very fabric of reality is constantly in flux. It's as if the universe is built on a foundation of tiny, unpredictable bubbles, each one a fleeting glimpse into the fundamental nature of existence. But what does this mean for the edge of the universe? If space itself is a frothy, turbulent sea at the smallest scales, could the boundary of the cosmos be just as chaotic? Some scientists believe that the edge of the universe might not be a smooth, well-defined line, but a dynamic, ever-shifting boundary, shaped by the same quantum fluctuations that create the foam. It's a concept that challenges our everyday understanding of space and time, suggesting that the universe's edge might be far more complex and far stranger than we ever imagined. Now, let's take this idea a step further. If space is a bubbling, frothy sea at the quantum level, could these fluctuations create pathways, tunnels through the fabric of reality? This brings us to the concept of wormholes, hypothetical shortcuts through spacetime that could connect distant parts of the universe, or even different universes altogether. Picture a wormhole as a kind of cosmic tunnel, linking two points in space that would otherwise be impossibly far apart. In the quantum foam, these tunnels could form and collapse in an instant, creating fleeting connections between distant regions of the cosmos. Wormholes aren't just science fiction, they're a natural consequence of the equations of general relativity. But here's the catch: while the math allows for wormholes, they're incredibly unstable. Without some exotic form of matter or energy to hold them open, they'd collapse almost instantly, making them impossible to traverse, at least with our current understanding of physics. Still, the idea of wormholes opens up a world of possibilities, from interstellar travel to the potential for connecting parallel universes. As we explore these ideas, we're reminded that the universe is far stranger and more complex than we ever imagined. From the chaotic froth of quantum foam to the tantalizing possibility of wormholes, these concepts challenge our understanding of reality and push the boundaries of what we think is possible. And as we continue to delve into the mysteries of the cosmos, we're not just uncovering the secrets of the universe, we're uncovering the secrets of existence itself. So, what's next? As we venture deeper into the quantum realm, we'll explore how these tiny fluctuations might hold the key to understanding the true nature of the cosmos, and perhaps even the edge of reality itself. The journey is far from over, and the answers we find could change everything we thought we knew about the universe. Now, let's dive into one of the most fascinating ideas in theoretical physics: wormholes. Imagine you're holding a piece of paper and you want to get from one side to the other. Instead of traveling across the surface, you fold the paper so the 2 points touch, then punch a hole through them. That's essentially what a wormhole is, a shortcut through the fabric of space-time, connecting 2 distant points in the universe. It's like a cosmic tunnel, allowing you to bypass the vast distances between stars, galaxies, or even universes. But how do wormholes work? According to Einstein's theory of general relativity, space-time isn't just a static stage. It's a dynamic, flexible fabric that can bend, stretch, and even tear. Wormholes are theoretical solutions to Einstein's equations, suggesting that space-time could fold in such a way that 2 distant regions are connected by a tunnel. These tunnels, if they exist, could provide a way to travel across the universe in an instant, bypassing the limitations of light speed. Here's where it gets tricky. Wormholes are incredibly unstable. Without something to hold them open, they'd collapse almost immediately. That's where exotic matter comes in. Exotic matter is a hypothetical substance with negative energy density, which could theoretically counteract the natural tendency of a wormhole to collapse. Think of it like propping open a tunnel with invisible scaffolding. Without it, the tunnel would slam shut, trapping anything inside. But what does this mean for the edge of the universe? If wormholes exist, they could provide a way to explore regions of the cosmos that are otherwise unreachable. Imagine a wormhole connecting our universe to another, or even to the very edge of our own. It's a tantalizing idea, one that blurs the line between science and science fiction. Now, let's take this a step further. If wormholes can connect distant points in space, could they also connect different points in time? This brings us to the concept of time travel. Some theories suggest that wormholes could act as time machines, allowing you to travel not just across space but through time as well. Picture a wormhole with one end moving at near light speed while the other remains stationary. Due to the effects of relativity, time would pass differently at each end, creating a kind of temporal bridge. Of course, this is all theoretical. Wormholes and time travel remain firmly in the realm of speculation. But they're more than just wild ideas. They're tools that help us explore the limits of our understanding, pushing the boundaries of what we think is possible. And as we continue to unravel the mysteries of space-time, we're reminded that the universe is far stranger and more complex than we ever imagined. So, what's next? As we venture deeper into the concept of time travel, we'll uncover how these ideas might hold the key to understanding not just the edge of the universe, but the very nature of reality itself. The journey is far from over, and the answers we find could change everything we thought we knew about the cosmos. What if the edge of the universe isn't just a boundary in space, but a gateway through time? The idea of time travel has fascinated humanity for centuries, but what if the key to unlocking it lies at the very edge of existence? When we think about the extreme conditions that might exist at the universe's edge, where gravity, dark energy, and quantum forces collide, it's not hard to imagine that space-time itself could be twisted, folded, or even torn. These distortions could create pathways not just through space, but through time itself, opening up the possibility of traveling to the past or future. Let's break this down. According to Einstein's theory of general relativity, space-time is a flexible fabric that can be warped by massive objects like stars and black holes. At the edge of the universe, where the forces of expansion and gravity are locked in a cosmic tug-of-war, space-time could be stretched to its limits. In these extreme conditions, the fabric of reality might become so distorted that it forms natural time tunnels, wormholes that connect different points in time. Imagine stepping through one of these tunnels and finding yourself in a different era, witnessing the birth of a star or the end of a galaxy. But here's where it gets tricky. Time travel isn't just about the mechanics of bending space-time, it's also about the paradoxes that come with it. Take the grandfather paradox, for example. If you traveled back in time and prevented your grandfather from meeting your grandmother, you'd never be born. But if you were never born, how could you have traveled back in time in the first place? This paradox highlights the deep complexities of causality, the idea that cause must always come before effect. If time travel were possible, it could fundamentally disrupt our understanding of how events unfold, raising questions about free will, destiny, and the very nature of reality. Now, let's consider another angle: cosmic censorship. This is the idea that the universe has built-in rules to prevent certain phenomena, like naked singularities, from being observed. A naked singularity is a point of infinite density where the laws of physics break down, but unlike a black hole, it's not hidden behind an event horizon. If such a singularity existed, it could create unpredictable distortions in spacetime, potentially allowing for time travel. But cosmic censorship suggests that the universe might censor these singularities, hiding them from view to preserve the stability of spacetime. So, what does this mean for the edge of the universe? If cosmic censorship is real, it could mean that the extreme conditions at the universe's edge are carefully regulated, preventing the kind of chaotic distortions that would make time travel possible. On the other hand, if cosmic censorship doesn't hold, the edge of the universe could be a wild, unpredictable place full of opportunities and dangers that we can't yet imagine. As we explore these ideas, we're reminded that the universe is far stranger and more complex than we ever imagined. The edge of existence isn't just a boundary, it's a frontier, a place where the rules of physics are pushed to their limits, and where the very nature of time and space might be rewritten. And as we continue to push the boundaries of our understanding, we're not just uncovering the secrets of the cosmos, we're uncovering the secrets of existence itself. So, what's next? As we delve deeper into the mysteries of time and space, we'll explore how these ideas might hold the key to understanding not just the edge of the universe, but the very fabric of reality. The journey is far from over, and the answers we find could change everything we thought we knew about the cosmos. What if the universe has a built-in curtain, hiding its deepest secrets from view? This is the essence of the cosmic censorship hypothesis, a theory that suggests singularities, those infinitely dense points where the laws of physics break down, are always hidden behind event horizons like a curtain drawn across a stage. In other words, the universe might have a way of keeping its most extreme and chaotic phenomena out of sight, preserving the stability of spacetime as we know it. To understand this, let's start with black holes. At the center of every black hole lies a singularity, a point where gravity becomes so intense that spacetime itself is warped beyond recognition. But here's the catch: we can't see the singularity directly. It's hidden behind the black hole's event horizon, a boundary beyond which nothing, not even light, can escape. This hiding of the singularity is what cosmic censorship is all about. It's as if the universe has drawn a curtain over the singularity, shielding us from its chaotic and unpredictable nature. Now let's take this idea a step further. If singularities are always hidden behind event horizons, what does that mean for the edge of the universe? Could there be a similar curtain hiding the true boundary of the cosmos? Some scientists believe that the universe's edge might be just as elusive, a place where the fabric of reality becomes so warped that it's impossible to observe directly. In this view, the edge isn't a physical boundary we can see or touch, it's a limit to our understanding, a point where the rules of physics as we know them no longer apply. But why would the universe hide its singularities or its edge? One possibility is that exposing these extreme regions would disrupt the delicate balance of spacetime, creating paradoxes or inconsistencies that could unravel the very fabric of reality. Think of it like a play. If the audience could see backstage, the illusion of the performance would be ruined. In the same way, cosmic censorship might be the universe's way of maintaining the illusion of order, keeping the chaos of singularities safely out of view. This idea isn't just theoretical, it has real implications for our understanding of black holes, the Big Bang, and even the ultimate fate of the universe. If singularities are always hidden, it means we might never fully understand what happens at the edge of a black hole or the moment of the Big Bang. These regions could remain forever shrouded in mystery, their true nature hidden behind the cosmic curtain. As we explore these ideas, we're reminded that the universe is full of mysteries waiting to be uncovered. The cosmic censorship hypothesis challenges us to think beyond what we can see, to imagine the hidden forces and structures that shape the cosmos. And as we continue to push the boundaries of our understanding, we're not just uncovering the secrets of the universe, we're uncovering the secrets of existence itself. So, what's next as we delve deeper into the mysteries of the cosmos? We'll explore how these hidden forces might hold the key to understanding not just the edge of the universe, but the very nature of reality. The journey is far from over, and the answers we find could change everything we thought we knew about the cosmos. The edge of the universe isn't just a mystery, it's the mystery, one of the most profound questions science has ever faced. Despite all our advancements, from telescopes that peer billions of light years into the cosmos to equations that describe the birth of spacetime itself, we're still only scratching the surface of what might lie beyond. The truth is, the nature of the universe's edge might be so alien, so far removed from our everyday experience that it's beyond human comprehension. Think of it like this: imagine an ant standing on the shore of an endless ocean. The ant can see the waves, feel the sand, and maybe even dip its antennae into the water. But can it truly understand the vastness of the ocean, the currents, the depths, the life teeming beneath the surface? Probably not. In the same way, we're like that ant, gazing out at the cosmic ocean, trying to make sense of something that might be fundamentally unknowable. And yet, here we are, driven by an insatiable curiosity to keep exploring, keep questioning, keep pushing the boundaries of what we think is possible. It's this curiosity that has brought us this far, from the first time humans looked up at the stars and wondered what they were, to the moment we discovered that the universe is expanding, to the theories we're crafting today about multiverses, higher dimensions, and the very fabric of reality. But here's the thing. Even if the true nature of the universe's edge is beyond our grasp, that doesn't mean we should stop trying to understand it. In fact, it's the very act of asking these questions, of daring to imagine what might lie beyond, that defines us as a species. Every time we build a new telescope, launch a new probe, or write a new equation, we're not just searching for answers. We're reaffirming our place in the cosmos as explorers, as thinkers, as dreamers. So, what's next? As we continue to unravel the mysteries of the universe, we're reminded that the journey is just as important as the destination. The edge of the cosmos might remain elusive, but the pursuit of knowledge, the act of reaching for the stars, is what makes us truly human. And who knows, maybe one day we'll find that the answers we've been searching for were closer than we ever imagined. Human curiosity is the spark that ignites every great discovery, the force that propels us to ask questions even when the answers seem impossibly out of reach. From the moment our ancestors first gazed up at the night sky, we've been driven by an insatiable need to understand the cosmos. What are those points of light? Where did they come from? And perhaps most tantalizing of all, what lies beyond them? This relentless curiosity has led us to some of the most mind-bending theories in science and philosophy, from the Big Bang to the multiverse, from wormholes to the holographic principle. Each idea is a testament to our refusal to accept the unknown as unknowable. Think of it like a child who never stops asking, why? Why is the sky blue? Why do stars twinkle? Why does the universe exist at all? These questions might seem simple, but they're the foundation of all scientific inquiry. Just as a child's curiosity leads them to explore the world around them, humanity's curiosity has driven us to explore the farthest reaches of the cosmos. And just like a child, we're not satisfied with easy answers. We keep digging, keep questioning, keep pushing the boundaries of what we think is possible. This drive to explore the unknown has given us tools like the Hubble Space Telescope, which has peered billions of light years into the past, and the Large Hadron Collider, which recreates the conditions of the early universe. It's led us to discover dark matter, dark energy, and the cosmic microwave background clues that help us piece together the story of the universe. But perhaps the most remarkable thing about human curiosity is that it doesn't just seek answers, it thrives on the questions themselves. The edge of the universe isn't just a scientific problem, it's a philosophical one, a challenge to our understanding of existence itself. And this quest isn't just about satisfying our curiosity, it's about expanding our horizons both literally and figuratively. Every time we uncover a new piece of the cosmic puzzle, we're reminded of how much we still don't know. The edge of the universe might remain elusive, but the journey to understand it has already transformed our view of reality. It's shown us that the cosmos is far stranger, more complex, and more beautiful than we ever imagined. So, what's next for cosmic exploration? The future holds incredible promise, from next-generation telescopes like the James Webb Space Telescope to ambitious missions to study black holes, gravitational waves, and the origins of the universe. Each new discovery will bring us closer to answering the big questions, and inevitably raise even more. But that's the beauty of curiosity. It's a never-ending journey, one that keeps us reaching for the stars, no matter how far away they seem. As we look to the future, one thing is clear. The edge of the universe isn't just a destination, it's a symbol of our boundless desire to explore, to understand, and to dream. And as long as that curiosity burns within us, the journey will never truly end. As we stand on the precipice of a new era in cosmic exploration, it's impossible not to feel a sense of awe at what lies ahead. Imagine humanity as a ship setting sail into uncharted waters, venturing into the vast, unknown expanse of the cosmos. For centuries, we've been building the tools and knowledge to navigate this cosmic ocean. And now, with groundbreaking advancements in technology and science, we're closer than ever to understanding the true nature of the universe's edge. One of the most exciting developments on the horizon is the launch of next-generation telescopes like the James Webb Space Telescope and the Nancy Grace Roman Space Telescope. These instruments are like the most advanced compasses and sextants, designed to peer deeper into space and further back in time than ever before. With their unprecedented sensitivity, they'll allow us to study the earliest galaxies, the formation of stars, and even the atmospheres of distant exoplanets. But perhaps most importantly, they'll help us map the large-scale structure of the universe, shedding light on the forces that shape its expansion and ultimately its boundaries. Then there's the growing field of gravitational wave astronomy, which has already revolutionized our understanding of black holes and neutron stars. Future detectors like the Laser Interferometer Space Antenna LISA will be able to observe ripples in spacetime from even more distant and cataclysmic events. These gravitational waves could carry clues about the universe's earliest moments, offering a glimpse into the conditions that existed at the very edge of time itself. But it's not just about observation. Theoretical breakthroughs are also paving the way for new insights. Advances in quantum gravity, string theory, and cosmology are helping us piece together the puzzle of the universe's origins and ultimate fate. For example, the holographic principle and the idea of a multiverse are pushing the boundaries of what we thought was possible, challenging us to rethink the very nature of reality. These theories might seem abstract, but they're the intellectual sails that propel our cosmic ship forward, guiding us toward a deeper understanding of the cosmos. As we embark on this journey, it's worth reflecting on the philosophical implications of these discoveries. What does it mean to uncover the edge of the universe if we find that the cosmos is infinite, or that it's just one of many in a multiverse? How does that change our sense of place in the grand scheme of things? These questions aren't just scientific, they're deeply human, touching on our desire to understand our origins, our purpose, and our connection to the universe. The future of cosmic exploration is more than just a quest for knowledge. It's a testament to our unyielding curiosity and our determination to push the boundaries of what's possible. With every new discovery, we're not just charting the cosmos, we're charting the course of our own evolution as a species. And as we set sail into the unknown, one thing is certain: the journey is just as important as the destination. So what's next? As we continue to explore the mysteries of the universe, we'll uncover not just the secrets of the cosmos, but the secrets of ourselves. The edge of the universe might remain elusive, but the pursuit of understanding is what makes us truly alive. And who knows, the answers we're searching for might be closer than we think. What does it mean to exist, to be human? These are questions that have echoed through the ages, from ancient philosophers to modern scientists. But when we turn our gaze to the edge of the universe, these questions take on a whole new dimension. Theories about the cosmos, whether it's infinite, finite, or part of a multiverse, don't just challenge our understanding of space and time. They force us to confront the very nature of reality itself. It's like staring into a cosmic mirror, one that reflects not just the stars and galaxies, but our deepest questions about who we are and why we're here. Take the idea of an infinite universe, for example. If the cosmos truly stretches on forever with no edge or boundary, what does that say about our place within it? Are we just tiny specks in an endless sea of stars, or is there something more profound about our existence? This idea has profound implications for philosophy and religion, challenging long-held beliefs about creation, purpose, and destiny. If the universe has no edge, does it have a beginning? And if it has no beginning, does it have a meaning? These are questions that have no easy answers, but they invite us to think deeply about our role in the grand tapestry of existence. Now consider the multiverse theory. If our universe is just one of countless others, each with its own unique laws of physics, what does that mean for our understanding of reality? Are we living in the right universe, or is there an infinite array of possibilities out there, some with life, some without? This idea doesn't just stretch the boundaries of science, it stretches the boundaries of imagination, forcing us to consider that our reality might be just one thread in an infinite cosmic fabric. And then there's the concept of the cosmic void, the idea that the universe might be surrounded by an infinite expanse of nothingness. If true, this raises haunting questions about isolation and connection. Are we alone in this vast emptiness, or is the void itself a kind of canvas, waiting to be filled with new universes, new stories, new possibilities? These theories don't just challenge our understanding of the cosmos, they challenge our understanding of ourselves, forcing us to rethink what it means to be human in a universe that might be far stranger than we ever imagined. This is where imagination becomes essential. The edge of the universe isn't just a scientific frontier, it's a philosophical one, a place where the boundaries of knowledge meet the limitless possibilities of the human mind. Just as a mirror reflects our image, the cosmos reflects our curiosity, our creativity, and our capacity to dream. It's through imagination that we can begin to grapple with these profound questions, envisioning worlds and realities that lie beyond the reach of our telescopes and equations. In the end, the edge of the universe isn't just a place, it's a metaphor for the limits of our understanding. And as we continue to explore these limits, we're reminded that the journey is just as important as the destination. Whether we're pondering the nature of infinity, the possibility of parallel worlds, or the meaning of existence itself, one thing is clear: the cosmos is more than just a collection of stars and galaxies. It's a mirror reflecting our deepest questions and our boundless capacity to seek answers. So, what's next? As we continue to explore the mysteries of the universe, we'll uncover not just the secrets of the cosmos, but the secrets of ourselves. The edge of reality might remain elusive, but the pursuit of understanding is what makes us truly alive. And who knows, the answers we're searching for might be closer than we think. What if the universe's edge isn't just a physical boundary, but a canvas for our imagination? Throughout history, it's been our ability to dream, to envision the unimaginable, that has propelled humanity's greatest discoveries. From Galileo's telescope to Einstein's thought experiments, imagination has been the spark that ignites scientific breakthroughs. And when it comes to the edge of the universe, a place we may never directly observe, it's our creativity that allows us to explore it, to paint vivid pictures of what might lie beyond the limits of our understanding. Think of it like this: a painter stands before a blank canvas, brush in hand. At first, there's nothing but empty space, but with each stroke, a world begins to take shape. The artist doesn't just copy what they see, they imagine what could be, blending colors and shapes to create something entirely new. In the same way, scientists and theorists use their imagination to craft models of the cosmos, blending observations with bold ideas to paint a picture of the universe's edge. Whether it's the multiverse, higher dimensions, or the holographic principle, these theories are like brushstrokes on a cosmic canvas, each one adding depth and detail to our understanding. But here's the thing: imagination isn't just about dreaming up wild ideas, it's about asking the right questions. What if the universe is finite? What if it's infinite? What if it's just one of many? These questions might seem abstract, but they're the foundation of scientific inquiry. They push us to think beyond what we know, to challenge our assumptions and explore new possibilities. And while we may never have all the answers, it's the act of asking these questions that drives progress, that keeps us reaching for the stars. Now, let's take this a step further. What if the edge of the universe isn't just a mystery to be solved, but a frontier to be explored? In a sense, the cosmos is like an unfinished masterpiece, a work in progress that we're all contributing to. Each new discovery, each new theory is like a brushstroke on that canvas, adding to the picture of reality. And just as a painter might step back to see the bigger picture, we too can step back and marvel at the beauty and complexity of the universe we're trying to understand. This is the power of imagination. It allows us to explore the unknown, to push the boundaries of what's possible, and to find meaning in the mysteries that surround us. The edge of the universe might remain elusive, but through our creativity and curiosity, we can continue to explore it in endless ways. It's a reminder that science isn't just about facts and figures, it's about wonder, about the thrill of discovery, and about the endless possibilities that lie just beyond the horizon. As we bring this journey to a close, let's take a moment to reflect on what we've learned. The edge of the universe isn't just a question for scientists, it's a question for all of us. It's a reminder of how much we still have to discover, and how much we can achieve when we dare to dream. So, as we look to the stars and wonder what lies beyond, let's remember that the greatest discoveries often begin with a single, bold idea, and that the universe in all its mystery is waiting for us to imagine it. As we reach the end of this cosmic journey, let's take a moment to reflect on the mind-blowing theories we've explored. From the observable universe, that vast sphere of light and time stretching 13.8 billion years into the past, to the tantalizing possibility of a multiverse, where countless other realities might exist beyond our own, the cosmos has revealed itself to be far stranger and more complex than we ever imagined. We've ventured into the realms of higher dimensions, where space and time twist into shapes we can barely comprehend, and peered into the quantum foam, where the very fabric of reality bubbles with chaotic energy. We've pondered the universe's ultimate fate, from the quiet fade of heat death to the explosive drama of the Big Rip, and even dared to imagine the existence of wormholes and time travel. These ideas aren't just abstract concepts, they're windows into the profound mysteries of existence. They challenge us to rethink what we know about space, time, and reality itself. And while we may not have all the answers, that's part of what makes this journey so thrilling. The universe is a puzzle, and every theory, every discovery is a piece that brings us closer to understanding the bigger picture. But here's the thing, the cosmos isn't just a collection of stars and galaxies, it's a mirror, reflecting our deepest questions and our boundless curiosity. It reminds us that we're part of something much larger, a story that began billions of years ago and continues to unfold with every passing moment. And as we explore these mysteries, we're not just uncovering the secrets of the universe, we're uncovering the secrets of ourselves. So what's next? The journey doesn't end here. There's still so much to discover, so many questions waiting to be answered. Whether it's the nature of dark energy, the existence of parallel universes, or the true shape of space-time, the cosmos is full of wonders waiting to be explored. And that's where you come in. Keep questioning, keep exploring, and keep imagining. Because somewhere, as Carl Sagan once said, something incredible is waiting to be known. If you've enjoyed this journey to the edge of the universe, don't stop here. Share your thoughts in the comments below. What theory blew your mind the most? What cosmic mystery keeps you up at night? And if you're hungry for more, hit that subscribe button and join us as we continue to explore the wonders of the cosmos. The universe is vast and the adventure is just beginning. Let's keep reaching for the stars.